So in PlayerTick, I do a number of different things. The tricky part is the mouse is in screen coordinates. It's just this flat plane, right, that we move the mouse along, but it's not in the game world, it's just on our screen. To get a world location so we can actually make our character follow the mouse, we need to convert the screen location that the mouse is on into the world location where we want the character. The way we do that is we use the dproject mouse position to world function that appears in the player controller class. And here's the documentation for that. It says it converts the current mouse 2D position to a world space 3D position and direction. We don't really care about the direction here in our 2D games, but in a 3D game, you would care about the direction as well. So we provide an F vector for the world location and an F vector for the world direction when we call this dproject mouse position to world function. And that's why I declared these two variables before I call the function. So now, after I call the function, when I get to line 23 here, world location is the location in the 3D world that corresponds to the location of the mouse in the 2D space of the screen. Now we want to move our character to that location, but before we do, I want to set world location.x to 0. Remember, we're keeping everything on the YZ plane, so I'm going to move the pawn to stay in the YZ plane. How do I actually get the pawn? Well, I call the getPawn function, and that gets the pawn that is possessed by this player controller. I will say that that actually returns an A pawn pointer, and because I need to call a function on an A character pawn, I need to typecast the results of that function call to be an A character pawn pointer, and that works because an A character pawn is a special kind of A pawn because I picked pawn as the parent when I created this script, and I put that into a variable called character pawn. Again, for safety, I make sure that that getPawn function worked fine by making sure character pawn is not a null pointer, and if it's not, I can now say on that character pawn pointer, call the function. Remember, this arrow notation is what we use if we need to call a function on a pointer to an object rather than the object itself. And then I call that setLocation function that I showed you earlier, and I provide the world location that I extracted from the mouse and set to the YZ plane. So back in the editor, I can now run my game, and I have this character. So Peak Game Studios actually built a number of games for the Pikes Peak Library District to use to teach fourth graders about Colorado history. And that was a 2D Flash game, but my 3D character modeler turned those characters into 3D models that we can use here. So this is one of the characters from that game. And as you can see, she follows the mouse around as I move the mouse around. Unfortunately, if I drag the mouse outside the screen, she leaves the screen as well, including top and bottom as well, of course. And there may be some games where we want to actually keep the player in the screen, and we'll address that particular issue in the next lecture. So this is all the code and all the setup to make our character follow the mouse around the screen. To recap, in this lecture you learned how to retrieve and use the mouse location in your Unreal games. The title of this lecture comes from a song by one of my favorite groups of all time, The Clash. So if you've never heard of The Clash or you've never checked them out, pause this video, go check out The Clash, and then come back. In this lecture, we'll learn how to clamp the character's location so the character stays fully within the bounds of the screen. More generally, we use the term clamp when we want to keep a particular value within a range of values or a set of values. To support clamping our character into the screen, I've added some constants for the screen. So we put them in a namespace called screen constants. The way I generated this particular script is over in Unreal, I created a new script with none as its parent, and then I added the code I wanted here and deleted some of the code that was in the default script that was provided. So in our header file, I've got a new namespace here. We've used namespaces before, but this time we're creating our own. And I'm declaring 4 constants for the left, right, top, and bottom edges of the screen. I will say that there's certainly a way to calculate those boundaries using characteristics of the camera and so on, but we're just going to set the constants because I know what the numbers are and this will be fine for us. So we've seen const and float and variable names or constant names before, but we've never seen this extern keyword before. Here's how it works. Constants in C++ have internal linkage by default. And what that means is those constants are only visible within this translation unit, not other translation units. So other translation units are loosely, although not precisely, the other implementation files in our project. And we want these constants to be visible from other implementation files. Specifically, we want them visible from the CharacterPawns implementation file. So we need to mark them as extern for external so that other translation units can access those constants. The implementation file for the screen constants just gives values to each of those constants. So this will be useful to the CharacterPawn to know where the left, right, top, and bottom edges of the screen are. Over in the CharacterPawn header file, I've declared some constants for the half width and half height of the character that we're using, and a vertical offset that I'll talk about when we get there. So the way I actually figured out the half width and half height for this character is I went to the actual static mesh and I opened up the static mesh editor, and over here on the left it tells us the approximate size is 6. I know that's the depth. By 25, I know that's the width by 32, which is the height. So this is sort of a rough way to get the size of the mesh. We could certainly, if we replaced the simple collision that was automatically added when we imported the mesh, if we removed that and added a capsule collider, we could access information about the height and width of that capsule collider, but that's overkill for what we're trying to do here, so we'll just use this information instead. So let's move to the implementation file for the CharacterPawn, and all our work will be in the setLocation function. Recall last time, all this function had was this one line of code. And I want to add some more lines of code to actually keep the character in the screen. I will say, because I'm using these constants from the screen constants namespace, I had to add a #include for the header file for those screen constants. So if you forget to do this and you try to compile, You get a number of compilation errors. The first one is the trigger for the rest of them, and it says screen constants is not a class or namespace name. So whenever you see that error message, your first thought should be, I forgot a pound include. Okay, so I've pound included screen constants, and Visual Studio takes a while to catch up to me, realizing that I've done that. But I'm going to use the clamp function in the FMath class to clamp location Y so that it falls between a minimum of left plus half width. So you should think about this. If I'm on the left hand side of the screen, I have my location on the origin or the center of my model, and mine is approximately in the center of my model. So the left side of where I should be able to move my character is left plus half the character width. And that will make it so the left side can't go past the left edge of the screen. Similarly, I make the maximum the right hand side minus half width, and I hand in the location I'm trying to move in. It makes sure it stays between these bounds, and I put that into location Y. I do something similar with Z, except that you'll see I'm using bottom plus half height plus vertical offset, and top minus half height minus vertical offset. And once we've clamped Y and Z to be within the screen, we set the actor location. But why do I need this vertical offset thing? So let me change it to 0, and I'll show you what happens after I compile, of course. When I run my game, my character follows the mouse around. The character clamps properly on the left and right, but if you look carefully, I can actually move part of her hat above the top, and I can move, she has black shoes on, I can move her shoes down out of the bottom. I will be honest, I don't really know why this is happening. I checked the simple collision that was imported, and it seems reasonably tight around the static mesh and everything, so it's not clear to me what's going on here, but I'm just going to force this to work properly by figuring out how to keep it in the screen on the top and bottom. That's a little unsatisfying to me, I will freely confess. I'd like to make this to be perfect, but since at this point anyway, I only have a single character, I can just figure out what this offset is and make it work in my game just fine. And although I strongly encourage game developers to try to figure out the cause of every problem that occurs and fix it in the most robust and elegant way possible, you've got to understand that there are certainly places in games where you decide that the time or the cost, or time is money, so the time and cost of chasing down a problem isn't worth it. And you just say, well, I'm going to fudge it and make it so it works fine. Obviously, horizontally still works fine, but vertically she hits the very top of the screen and the very bottom of the screen as well. So while I don't encourage people to just put those fudge factors or kludges into their games, sometimes. To recap, in this lecture you learned how to clamp the pawn's location so it stays in the screen. In this lecture, you'll learn how to use action mappings to process mouse button input in your Unreal games. We'll start with our project from the previous lecture, and the first thing we'll do is we'll add the input mapping that we need to process input. We go to Edit Project Settings and select Input on the left, and we have two kinds of input mappings that we use here. We have action mappings and we have axis mappings. So action mappings are for discrete events, a button press or a button release, something that happens once instantaneously. Axis mappings are used for continuous input, like using the WASD keys to control a character or something like that. So we don't need axis mappings in this lecture, though we will need them when we start doing keyboard input, but we do need one action mapping. We want to destroy our character when the left mouse button is pressed. So an action mapping is the correct choice here. So I will add an action mapping, and sometimes you'll have it show up like this and you'll need to expand with that little left arrow, and I'll say destroy character. Now it's important that you remember exactly what you type here for the name of this action mapping, because you're going to need to use it inside the C++ code. It is also sometimes the case that it shows up like this when you add it, and so you need to expand it. And right now there's no key binding to this particular action mapping. The way we add a key binding is we click this drop down and we can pick which device we're using. In this particular game we're using the mouse, and we want the left mouse button. So now we've mapped the left mouse button to the destroy character action. We've added that action mapping to our game. The next thing we do is we add some code to our character player controller script. We need to add two functions to this script. The first one is the setup input component function, which, as this comment says, is what we use to bind functionality to input to make it so our code can respond to that action mapping. The other thing we need to add is a function that destroys the character pawn, the function that will actually get executed when that action mapping occurs. In our implementation file, first we check that our input component field is not a null pointer, and we are supposed to automatically get a pointer to a uInput component object when we start up our player controller. That should be initialized. So this is just a safety check to make sure that we did in fact get that pointer. If we did get that pointer, we want to use our pointer to that uInput component object to call. Remember this notation, the arrow notation, when we're calling a function from a pointed to object or from a pointer. And we want to use the bind action function. The first thing we do is we provide the name of the action mapping we're trying to bind behavior to. And this is why you need to remember how you actually named that action mapping. The next thing we provide is what event on that mapping do we want to respond to. So if we look at the eInput event enumeration, we can see that we can respond to a pressed input event. For us, on the left mouse button, we can respond to it to being pressed. We can respond to it being released. We can respond to double clicks on it. There are a variety of different input events we can respond to on this particular mapping. And I know I got really excited when we were spawning teddies to show you how we could use an enumeration when we were setting the spawn location, and then I admitted we didn't really need the enumeration there, but all that stuff that I talked about for enumerations back then applies here for using the enumeration. The third argument says this player controller is the one that's going to respond to the action occurring. And finally, we have to say which function should we call to respond. And we don't provide just the function name. We actually provide a pointer to the function. So we've spent time talking about how variables are stored in memory, and we haven't really talked about the fact that functions, the executable binary instructions, are also stored in memory. And so we can provide a pointer to the function, and the Unreal Engine will know to go to that memory address to start executing the function. So that's how address of works for functions. And so we're telling it, if this occurs, if the left mouse button is pressed on the action mapping called destroy character, the engine should call the destroy character pawn function. The destroy character pawn function is pretty straightforward. We get a reference to the pawn that is currently possessed by this player controller, and we've already seen this code above when we make the pawn follow the mouse on player tick. And then once we get access to the character pawn, we just tell it to destroy itself, and that destroys the pawn that's possessed by the player controller. So back in the editor, when we run our game, we move the character around like we used to, but if I press the left mouse button, then the character disappears. So that's how we can use an action mapping to respond to a discrete input event in our game. To recap, in this lecture you learned how to use action mappings to process mouse button input in your Unreal games. Last time, we finished up with mouse input processing in our Unreal games. In this lecture, we'll learn how to use action and axis mappings to process keyboard input in our Unreal games. We'll start by setting up our input mappings. So edit project settings. And I've already done it. So I've set up one action mapping for a discrete input event. Pressing the spacebar will destroy the miner. We have a miner as a character in this particular game. And remember, axis mappings are for continuous input, like for movement. And that's how I've set these up, so we can move horizontally using the right and left or D and A keys or some combination of those. And we can move vertically using up, down, or WS. I want to point out in the horizontal axis mapping that I've set the right key and the D key to have a scale of +1, and I've set the left key and the A key to have a scale of -1. And that's how we'll end up moving to the right on right or D, positive along the Y axis, and how we'll end up moving left when we use left or A, going negative on the Y axis. So this is the setup of the action mapping to destroy the miner like we were destroying our character last time with the left mouse button, and axis mapping so we can provide keyboard input. As you can see, we have our typical game mode that I've customized in the usual way with the pawn and the controller. We have a miner pawn and we have a miner player controller for our C++ scripts. So let's go take a look at the miner pawn first. In the header file for the miner pawn, I have some private constants for half collision width and half collision height like we've seen before. I did need another kludge factor in height and I just added it into the number there. But we need this constant as well. We need to know the speed of the pawn. How far can it move per frame? So this is the speed if we have movement input. We didn't need that when we were following the mouse around. There was sort of no speed at which we moved. We just moved to the mouse location on every frame. But here you can think more of we're pushing the miner around with our keyboard input. So we have to know how far the miner moves when it has keyboard input. And that's what this gives us. Scrolling past the default stuff, we have a move horizontally function that will move the miner horizontally, no surprise, and move vertically to move the pawn vertically. In the implementation file for the pawn, we are going to tick every frame, and I'm going to move past the tick function and then we'll come back to it. So when the move horizontally function gets called, what we do is we add a movement input for this pawn. We could actually just move the pawn right here, but it's a better approach to actually use the movement input system that is in place in Unreal. So we're going to add a specific movement input. We get the actor right vector, which is the positive y-axis. So we say we want to move along the positive y-axis, and we want to move by move scale times move amount per frame. Now I will say that by getting the positive y vector, if move scale is negative, we press the left key, for example, then this will be negative. So we'll be applying a negative movement input along the positive y-axis, which moves us to the left. And we do a similar thing down here with move vertically. So if one or both of these functions are called, we'll have some movement input that we've added because the functions were called. Back in the tick function, I have an f vector called pending movement input, and I call this function called consume movement input vector. So what happens is, adding movement input in these functions down here build up a movement input vector that I can consume here to find out if there are any movement inputs waiting to be processed. If y isn't 0 or z isn't 0, that means I have movement input on at least the y-axis or the z-axis. I might have it on both, but I have it on at least one. And I want this if statement because I don't want to do all this work in here unless I'm actually processing movement input. So first thing, I get the actor location and I put it in an f vector called new location. For y, I add, so now I'm changing the location in y. I add the y component of the pending movement input, and I clamp on the screen for y. For z, I add anything that might be pending in z, and I clamp in z, and then I set the actor location to the new location. So this is the pawn having functions called on it saying you should handle movement input, and on tick actually processing any pending movement input. I should have mentioned, when we create a pawn with pawn as the parent class for our C++ script, we actually get a default function for setting up the input component. And I just deleted that. I'm not handling any input in the pawn. I'm doing all that work in the player controller instead. So speaking of the player controller, here we are. We've seen this function before when we added this function in our mouse button processing so that we could bind to the destroy character action. We also have here, we want to be able to move horizontally. We want to be able to move vertically. And we want to be able to destroy the miner. So I've added those functions for movement processing and for that action mapping for destroying my miner. Finally, in the miner player controller implementation file, I've added my setup input component function. And this stuff is new. Well, the assert isn't new, right? This is just making sure we did